we did a comparison of Tempris in a lab scale environment with thermocouples, the traditional thermocouples which we still use. But again, thermocouples won't be available in other scales. And what we did is basically use thermocouples in center positions, in hour vials and edge positions. Center positions are the dark bluish thermocouple profiles here, which you can see, and the red and orange profiles are thermocouples and Tempris data from edge vials. So vials which are at the corner, at the edges of a shelf, for example. To make a long story short, we found that Tempris is perfectly matching data which we obtain with thermocouples, which basically means we can compare these two, Tempris and thermocouples. We can use thermocouple data during development. It's much less expensive. And then use Tempris as a temperature probe for our last runs, which we want to scale into production. And also something we did here is to compare Tempris and thermocouples with a batch method called manometric temperature measurement. That's a technology which allows you in a certain environment to collect certain pressurized data, and these pressurized data give you a temperature measurement answer. And essentially, what we found is that even these data match with thermocouple and with Tempris data. This has been published a few years ago, and that's well known basically, but it's important to highlight that these data are comparable. So it's nothing which is there's no huge bias between these technologies. And we found one big benefit for the Tempris probes, because the tip, the temperature sensitive tip, is a little larger. It shows benefits in terms of endpoint determination, because it won't lose contact to ice that early compared to thermocouples. Thermocouples tend to lose ice quickly, contact to ice quickly, and then basically indicate an endpoint a little earlier than, for example, we would see that with Tempris probes. That has a benefit in endpoint determination. And this is data from a scale-up cycle from lab to production. This is the lab scale data. Again, thermocouples, they are always in the package. You would always use thermocouples in the lab. But again, along with Tempris probes, the Tempris probes are highlighted with a bright bluish data profiles here in the center. Dark bluish thermocouple data, and they are first of all matching. Second, you see or you can define a certain design space and temperature control for that lab scale cycle. That would be the range -25 up to maybe -22 for center and edge vials, and you have a criteria for endpoint determination for that lab scale cycle. And basically that was developed or considered as the cycle, the one to go to production. And this is production data where we used Tempris in that scale-up technical batch. The Tempris probes in red, the RTD data in bluish. And if you look at the Tempris data, they kind of match each other. They are very matching. The profiles are very much matching each other, which is good, because if you look at the RTD data, position in corner, positions on the shelf, you see a tremendous bias between profiles. So think about having no Tempris data at all. You have to make a decision which of the RTD data is your reference for scale-up. What is your product temperature profile? It's getting you nowhere, okay? There's no chance to get an answer. Certainly easier in the lab, but how to define your design space, how to define your appropriate cycle conditions based on the bluish lines. It's very difficult. And here with Tempris, first time to get a chance, get a readout, we see in the plateau phase, it's approximately -30, the temperature profile. And here in our lab scale environment, we are in average at -25, -24. So as expected, the product runs colder in a production environment, which is typically the case. It's well known, but what is the level of colder? And here you can quantify that by having the Tempris data on hand. So just as a quick summary and conclusion, essentially we do need product temperature measurement to get a final high quality product in freeze drying. We need representative product temperature measurement in both lab scale and production scale. We need the same technology. Doesn't matter what technology for someone as a consumer of temperature measurement, but at the moment it's not satisfying to have an apple with peaches comparison. We need an apple with apple comparison. And Tempris is, among others, the most leading and the most promising technology at the moment to have that comparison. Besides invasive product temperature measurement, there are also non-invasive product temperature measurements. That's again a different story, a big topic, and the appropriate combination in the future of non-invasive batch methods and invasive single vial methods would be the way to go in a reliable PET strategy for freeze drying.